Um, let's start. The speech data encryption method based on the redundant residue number system. Who will be speaker?
Hello, I will be speaker.
Okay, Sergey, and I'd like to admit to all of you that according to schedule, we have 7 minutes plus 3 minutes for questions, please.
Only 7. Okay.
Okay.
Uh, Good day, everyone. I am very excited to start the second chat with my topic, data encryption method database on the redundant residual number system. Relevance. One of the key tasks of cybersecurity, as we know, is data protection, one of which is data backupping using distributed data storage system. Distributed data storage system allow data to be delivered into fragments that can be located on physically removed devices or cloud services, which complicate physical access to the information. In the event an attacker gain access to part of the data or one of the storage services, using encryption and storing the sequences on different devices protects the data and makes the decryptions impossible. One way to divide the data into parts is to use the redundant residual number system. According to it, data is divided into fragments, which reduce the number of bits and increase the speed of performing arithmetic operation, especially when processing long message, for example, when hardware implementation of cryptography algorithms. Data conversion in RNSN is carried out according to the Formula 1. The received residues are written into files and stored in the network or distributed data storage. The reverse conversion of data from sent to the positional number system is doing according to the formula 2. So P is the total range and BI as the base number of the RNS. Data encryption. To detect errors in RNSN, an extended system of modulus is used, where key is the number of modulus of working range and hash is working range. If an error occurs in the residues one of the modulus, the value x big will be obtained as a result is will be outside the working range. So according to data encryption, the value of the modulus should be selected so what the working range meets the following condition. To encrypt data, it's necessary to perform the following steps of the algorithms. First, choosing the size of the encryption block. Two, selecting the number of relatively prime modulus. 3. Selecting the value of the relatively prime modulus. 4. Converting the data block into decimal format. 5. Converting the data block into the RNS according to the Formula 1. 6. Coding residues into the optimal volume format. 7. Recording the residues into N files to store them on distributed media. When attempting unauthorized data access, the intruder needs to determine the number and the value of modulus, which have been used to encrypt the data. So according to the asymptotic distributed of prime numbers, the amount of prime numbers from 0 to some q is determined by the formula 3. If we using S-bit numbers, the range q can be represented as you can see like formula 4. When we using system of n modulus, the number of combinations that we need to check can be obtained by formula 5. When modulus bit size is bigger, so we need to use another formula like formula 6. So complexing of direct and inverse transformation based on the Renaissance, we can determine dual formula 7 and total computability complexity of the cryptanalyst algorithm will be obtained by formula 8. As we can know, the smallest system may have two modulus information and one check modulus, so n equal 3. Table 1 shows the depends of the total complexity of the cryptanalyst algorithm on the bit size of modulus. The result of this study shows that depends of the complexity of the cryptanalyst algorithm does not change and stay in a line L when the bit size of the residuals is increased. In cryptography, one of the methods used to estimate cipher strength is brute force attack. Currently, one of the most common data encryption is IS 128 bits symmetric key. Based on the conducted research, we select the modulus whose bit size is similar to the use of the IS algorithms. See in table 2. Based on Formula 8, we determine the dependence of cryptography strength on the size of the file with residuals, as you can see in table 3. So the complexity of the method description is calculated according to the next formula. In order to increase the level of the encryption algorithm cryptography strength based on the RNS, we propose to an improvement of the encryption method by changing the position of the residuals using pseudo-random sequences as scaled on the screen. So on figure 1, you can see the proposed encryption method based on RNS. It is proposed to write calculate residuals to the file of residuals without change if secret k is equal or 0. In case when the value of sequence is equal to 1, the residuals are recorded in the following file of residuals, and the last residuals is recorded into the first like you see on the figure 2. The residuals are shaped according to the value of the pseudorandom sequences. Consider that the RNS is non-positional system. The shift of the residuals by one position make it difficult to restore the data. Even if the attacker knew the system is unknown, an attacker will not be able to take the basic file. So to recover the correct sequences or residuals, an attacker must sort through all possible residuals in all residuals files. Therefore, the difficult of sorting value with the shift is determined by the formula 11. In table 5, you can see the complexity of sorting residuals by an attacker with unknown modulus. So taking into account all of the above, it is possible to determine the cryptography strength of the system with the modulus up to 16 bits, as you can see on table 6. Conclusion. The method for data encryption based on RNS and the residual shift by M sequences K is proposed and investigate is this work. It's proposed to reduce the minimum length of the message, which make it possible to reduce the bit size of modulus necessary to achieve the specified level of protection. The proposed method provides higher cryptography strength, as that is the classic method. In our opinion, the most promotion area of future research are following. One, studying the impact of other types of attack on the proposed encryption method. Two, investigate the cryptography stage of the algorithm when increase the number of the RNS modules. And three, studying the prospect of using the proposed approach to encrypt of medical images. Thank you for your attention. Any questions?
Thank you, Sergey. Colleagues, any questions, please? Yes, Vyacheslav, please.
Yes, thank you very much for your presentation. My question is the following. As we know, residue number system initially was developed as a technique, as method to improve reliability and fault tolerance. Yes, you apply this approach, this methodology to improve security issues. What about reliability? If we talk about application of this methodology for improving of cybersecurity. What about reliability issue? Did you research measures of reliability in this case? And balancing of reliability and
thank you for the questions. We just in this article, we try to learn more about complexity cryptography strange, because the reliability is one of the position, but if we speak about cybersecurity, the most important problem is to get higher defense from taking information by another users, not authorized users. So in this work, we focus on this problem.
Thank you. I understood, but my question concerns additional problem with decreasing of reliability if we apply such means to improve cybersecurity. Hence, we get more complex system in comparing with initial decision. Hence, maybe it can be additional direction of research, because I think in general dependability measures we need to balance as security and reliability as well.
Yes, I agree with you, but it's not the most learning problem in this topic. So I thank you for the questions.
Thank you.
Okay, colleagues, any more questions? Okay.
Thank you.
Bye. Thank you. So let's move on. Who will be speaker, Vyacheslav or Oksana Kovton? Are you ready? Click. Who will be present report service-oriented model for handling MTC subscribers traffic in a 5G cluster? Okay. Vyacheslav, please. Actually, we do not hear you yet. Say something for test. We see presentation, but we do not hear you. Is it possible to fix it? We see that you have microphone, but it's not active. Mhm.
I'm sorry, can you hear me now?
Okay, we hear you. Thanks,
Oh.
super.
Yes, I'm sorry for delay. Give me a second, please.
It would be better for more loud the sound, but it's okay. Mhm. Please, you have 7 minutes, please.
Sorry about. I'm sorry. Okay, I hope that now you see my presentation, and let me present the results of investigation named service-oriented model for handling MMTC subscriber traffic in 5G cluster. I'm Vyacheslav Kovtun, and here is this presentation. First of all, let me say a few words about motivation. So in the list of technologies proposed by the 5G standards specification, the support of massive machine type communication holds a prominent position. The implementation of this technology is very important when we talk about Industry 4.0, because the MMTC technology is specifically designed to address the plethora of issues related to organizing information interaction around sensor networks. However, any system operations predictably and efficiently only if its structure is transparent and optimal in the context of its intended purpose. Therefore, the research task of the rational organization of the data collection process from multiple sensor networks, which finite number of terminals located in the velocity of 5G cluster is relevant, and that's why we choose this topic. Most of the analytical models that operates in such a direction are based on Quaquin system mathematics. So we also based our research in this direction, and let me present the object of the research, which is the controlled process of uplink transfer of segmented information messages from a finite set of terminals belonging to different sensor networks deployed in the coverage area of the target 5G cluster. The subject of the research is the elements of query theory, Markov chains, and functional analysis. The aim of the research is to streamlining approach to analytical assessment of the quality of the service-oriented controlled process of handling MMTC subscribers traffic in the 5G cluster. Now let's present our model. The focus of our research is on the 5G cluster, whose base station is capable to distributing communication resources in the amount of V units. Within the coverage area of the investigated cluster, mobile network operators potentially can offer subscribers specific services, the list of which is generalized by the set S. In the context of cooperators, provides the subscribers within the list of services generated by the subscriber SK. So we also take into account the numbers of services which was chosen by the subscribers, which represents by the parameter NKS, and general amount of this parameter is generalized by the indicator N. We formulate a model of investigation process based on the Quequin systems theory. Suppose N subscribers direct a request to the base station to activate available services in the portfolio of the operator, each of which is associated with a corresponding virtual network segment. It is assumed that a subscriber cannot submit new request until the receiving the response regarding the recently submitted request. Based on the created model, we formalize the quality metric. At no values of the indicators in the Quequin model for the target service-oriented MMTC traffic subscribing system in the 5G cluster, it is possible to calculate the metric of performance indicators, including the probability of losing an incoming request due to the system overload and the average duration of requests stay in the system, including the average service duration and the average duration of requests stay in the buffer, and the average number of requests in the system, including the average number of requests in the service stage and the average number of requests in the buffer. So, based on the proposed mathematical model, we made some experiments. To demonstrate the informativeness of the proposed quality metric, we calculate the corresponding dependencies in the specified total volume of 16 megabits of communication resource in the base station for the investigated 5G cluster. The results of the calculation is present on the figure 1. The graph presented on the figure 1 shows that the quality indicators are sensitive to the increasing intensity of incoming requests from the subscriber terminals to the base station of the investigated 5G cluster. Also, we complement the information presented on figure 1 by calculating the quality metric indicators for the investigated instance of the 5G cluster. The calculation result visualized in the form of the graph presented at the figure 2. As expected, the shape of the dynamics of the graphs of the dependency presented on the figure 2 are most similar to the results shown on the figure 1. That means that model and the real object are the model is adequately described the real investigated process. So in conclusion, we want to say that to address the research task, the article proposes the Markov model of the controlled process of uplink transfer of segment of segmented information messages from the finite set of terminals belonging to the different sensor network deployed in the coverage area of the target 5G cluster. The segmentation of sensor networks at the model level is ensured by the service orientation in dedicated virtual network segments organized in the information environment of the 5G base station. The model serves as the basis to formalizing the metrics of quality indicators, including the probability of losing information, losing incoming requests due to the system overload, indicators of average duration of the requests stay in the system, and indicators of the average number of the requests in the system. Thank you for attention.
Okay. Okay, colleagues, any questions, please?
What software did you use?
General experiments was conducted in the I'm sorry, Origin Pro software. Origin Pro software. I don't hear you. Can you hear me? Can you hear me?
Thank you, thank you.
Okay, Vyacheslav, please.
Thank you, Vyacheslav, for your presentation. Nice to hear and see you. My question is following. Are you planning, do you planning continue your research in context of more reliable or maybe more dependable questions of research? I mean, this system which you present is very, very complex and very important, and actual is aspect of evaluation of reliability measures. And your Markov model could be extended considering failure states.
I think, thank you for your question, Vyacheslav Sergeyevich. I think that in such a presentation, this model can be used for adequate assessment of failure states because it is focused on the metric that I presented. As you clearly indicate, this object of study is very complex. That's why to present the model that can be applied for any task, it is very not only easy, but also not practically in practical interest, because such a complex model can be calculated. So that's why this model is focused on the metrics that I present. But speaking about your question, it is interesting direction for adaptation of this object to such an assessment that you indicate. Maybe we can discuss this at the DCERT conference this autumn, I hope.
Okay, thank you. Welcome to the.
Thank you very much.
Okay, colleague, thank you for your questions. Any more questions? So we have to move on.
Thank you.
Okay, colleagues. The next speaker will be Olga Fedevich. One question to colleagues. Do you hear the speech?
Рекламочки я где, Сергей?
No here.
I see. So maybe I'll that's due to some problems with let's go to next presenter and we will hear this report later after fixing these technical problems. So the next speaker will be Mykola Stetsuk. Are you here?
Hello everyone, I'm hear you, and now I'm begin my
Okay,
presentation.
Mykola, you have 7 minutes, please.
One moment, please. I'm start my presentation. Hello everyone. I want to present you a report on the topic the DDoS attack on scenario model on it's like information technology elements and contribution against cyber attackers. The complexity of ensuring stable operation of modern specialized information system has recently been constantly increasing due to more frequent cases of attack implemented by malicious software. These district effects are carried out by offenders using computer attack, which aim to make the function implemented by special information system unavailable or difficult to access. This result of influence of malicious software is blocking or multifunction or complete impossibility of operation computer system. The DOS attack occupy a special place among computer attacks. The prevalence of this type of attack due to simplicity of their implementation and serious consequences of their implementation. The DOS attack can be implemented at almost any level of cyber network protocol by computer system to communicate, more often sort of 4 and 7 level. According to the National Cybersecurity Coordination Center of Ukraine in 2024, every with 5 Ukrainian company state organization experience DDoS at the same time attacks at most targeted large bank, 27%, medium and small business. DDoS were aimed at creating problems in the work of the websites of both state institutions. And the business 39% of attacks disabling communication service and access to information systems. This task of assessing the capability of malicious software to carry DDoS on specialized information system is one of the most urgent scientific tasks today. Today, one of the most convenient technologies for building computer network organization and companies is MPLS, a multi-protocol network technology which combines the technology of virtual channel with the functionality of the TCP/IP stack to the fact that the same network device performs the function of the both of IP route and switch virtual channel, allows you to combine territory separated path of information system combined into a single local network. It's extremely convenient. That's why the technology is chosen as a basic on when creating a mathematical model of the DOS attack. Let's analyze the progress of the DDoS. Its implementation is preceded by some preparation action. An attacker needs to perform network recognition of information system chosen for the attack by performing a number of steps. For this, he needs to determine its active elements, type, and the version of operating system as well as network service. We denote the average time spent on its first and their distribution function. 2. Respectively, the attacker successfully implemented this action with probability 3, respectively. If the attacker failed to set the least one of the network parameters, then his attempt will be repeated with probability, respectively, with the average repetition time and the distribution function. In the next step, the attacker analyzes the received data and determines vulnerability of the element of the attacker network for the average time spent. 7. With a time distribution function. In the future, the attack determines the request to connect to the server, the attack target of the attack in average time. 9. Which time is the time distribution function. 10. And probability of connection to the target server and receiving a response about the state after the time. With distribution function 30, if access is not obtained, the attacker sends a repeated request in average time. 15, which distribution function 16. To launch the DOS, the offended activity the bot network and indicate the target of the attack. Each bot starts sending service request to the attack object with an average time 17, which the time distribution function is 18. Blocks of information system section using a DDoS is carried out in average time 19 with the distribution function 21, the average time 22, and the distribution function ft of the time of the offended implementation of DDoS are to be determined. Now we can present the process of organization DDoS attack in the form of a stochastic network, figure 2. Here is the function 23 replaces intelligent transformation of the corresponding distribution function specified in the statement of problem in definitive formula by 1. To determine the equivalence function, we closed the input and output of the stochastic network with a fictions branch according to the formula 2. Let's define loops of the first and second orders in stochastic network model with assumption the values of probability third and 11 are equals to the same value Pn. Based on Mason level 3, we get the equivalent function of stochastic network. Since the function 4 is characteristic different allows finding the initial and final moments of random time of implementation of DDoS determined by formulas 5 and 6. From expression 5 and 6, we get the formula for determining the average time of DDoS implementation. The variance of DDoS attack implementation, which defined as second central moment, is represented by expression 8. Calculation of mathematical expression and dispersion allows to determine with scientific accuracy the distribution function of the time of the successful implementation of the DDoS attack as an incomplete gamma function. Calculations were made using the formula 9 is in the mode of the MATCAT application program package, the result of which are present in the graph. As initial data, the value of the average time used by attacker to implementation detect of DDoS and given in table 1. The values of probability Pn in application are taken equals 0.35, 0.9. Conclusion: the analysis of obtained results shows that the development model of the scenario of implementation DDoS attack by an attacker on the elements of specialized information system is scientifically sensitive to changes in the initial data, allows obtaining consequent results, adequatives, and the possibility to determine the probability time characteristic of attacker's cyber influence system. The simulation result shows that the main influence of the success of DDoS information system is carried out through the parameters that can become available to him as a result of intelligence of information system network, notes of the method identification and identification of legitimate users. Thank you for your attention. Any question?
Thank you, Mykola. Colleagues, please, any questions?
Do you plan used neural network?
Yes, but we have to prepare our models for this because network AI, if you say about this, it's a lot of methods and we must prepare for this.
Thank you.
Thank you for your question.
Okay, colleagues, some more questions? Mykola, what is the disadvantage of your research? Maybe you have some items to be improved, fixed.
If I understand you correctly, the DDoS attack is very large, and we have fixed our result in our market and our real and research, and I don't understand how to explain in English.
Okay, thank you. So, as you understand, there are a lot of attacks, and you
Thank you
have
for your
to. Yeah. Yes. Okay. No more questions. So let's move on.
Thank you for your attention.
So. So let's try the second prompt. Okay, do you see the presentation?
We see, but cannot hear.
Okay.
Good afternoon, dear colleagues. I would like to present to you our work, which is called Decision-Making Logic in Operational Emergency Situation for Hierarchical System Management, made by Lyubomir Sikora, Natalia Lisa, Olha Fedavich. So let me start. Agenda of our presentation: motivation and state of the art, purpose, research object, research methods, main results, and conclusions. System analysis arose, as you all know, as a result of attempts to apply the methods and tools of systems theory to solve different problems of managing in complex hierarchical systems in normal and emergency mode. With the development of man-made structures, information barriers arose as well, which formed complex management tasks. For example, like increasing bandwidth of data transmission channels and rapid growth of their caloric complexity of the problems to be solved. Exceeded the ability to process data flows by humans and the processor of the automated control system in technological process. So, and the purpose of this study is to describe and develop decision-making logic in operational emergency situations for hierarchical systems management, which we can see. Of course, management failure, accidents, problems, systems. Research object is a system, goals, and system. objects of spatial distributed integrated production facilities. What we've used, methods of system analysis, of course, of the structure and dynamic of production infrastructure components with a given goal orientation. Logical and cognitive models for assessing the ability of personal pressure situations, methods for assessing the risks of emergencies, terminal control cycles using cause and effect diagrams. And let me start with the main results, which will be the exception. This is also the complex. There are the following levels: hierarchies. Hierarchy of structure of units. Hierarchy and order control structure, which depends on targeting, orientation, and mesh processing, sensors, processing units, image formers of dynamic situations, and so on. Hierarchy of the decision tree. Hierarchy of priorities and procedures for writing alternatives in the target space. Hierarchy in the construction of sets of goal trees and corresponding classes of strategies. So, depending from this, I will hierarchies forward and reverse process. Important in the procedure for finding a way to solve problems in the acquisition for identifying knowledge in an active diagnostic and estimate, identifying neurological and cognitive structure. The next step is to isolate the control objects from the environment of the technogenic system and define its boundaries, functional and informational structure. Build a formalized model, assess its adequacy, identify limit and emergency mode, and accordingly observability and controllability. The responsible procedure in the object aggregation scheme, construction of a mathematical model. Hierarchy of source and information components of the system in the form of a scheme for structuring actions. SADI model and the in-level model for assessing local and global communities. At the same time, which I've already talked about, there are hierarchies of forward and resources. The next stage in the hierarchy of procedures for streamlining the stages of action planning and structuring management system in accordance with the global goal. You can see here the systematic analysis of the problem needs formalization, identification of critical zones in the space of goals and states of the object, the composition of the problem, the construction of scenarios of possible events, selection of means to achieve the goal, both local and global, and appropriate scaling of the goal space for its structuring, methods and models for assessing the situation in the system as the main means of identifying the information structure of processes in the system and the logic of decision making. Identification and logical contradiction in the process of decision making and assessment of dynamic situation as well, taking into account causal relationships in the scenario of events and building categories as a way to display information structures, building strategies for coordinating team actions and setting the level direction of risk. And two more, analysis of the degree of coordination of their action, context of the implementation action plan, advice to resolve conflicts all levels of the integrated hierarchical automated control system, development of coordinational strategies based on the information and regulatory framework, and the construction of appropriate algorithms with justification of their logic structure. In accordance with the current situation, let's describe hierarchical structures as an organization for implementation of standard tasks, taking into account tasks and threats of cognitive component of the operator. After defining all of those strategies, we have developed the structure of the system with feedback, which you can see on the picture, as well as describe it in detail in mathematical and systematic parameters for described structures. But I want to omit it because we won't have time to discuss it. And you can see it in the article. Based on the above analysis of the structure and functionality of hierarchical systems and the external and internal threats control models, there is of conclusion about the training of international personnel and their knowledge. The modern development of the science of intelligence is based on the three aspects of cognitive functioning that were not taken into account in the IQ concept. Competence, conscious knowledge base, pragmatism of thinking procedures, and mental potential for problem solving. Blocks of knowledge are necessary for performing professionally oriented activities are formed in the process of learning based on the ordering acquired in the past and not the advanced. So this is first part. This is the second, right? The information and cognitive fitness of operational personnel. Here we have the risk assessment, cognitive trust coefficient, and coefficients of knowledge requirements from left to right. And to sum up, the article considers certain aspects of the use of logical and intellectual procedures that form the basis of the scheme for synthesizing hierarchical control systems. Based on the construction of hierarchical systems with different functional structure, an approach using the logic of functions theory of situational management is proposed. Models of the structure of system for active control of technological processes under condition of dynamic instances of systemic structural and the concept of goal orientation forming control decisions. The system is a hierarchical structure. Visions, threats, and information as the basis of the synthesis of advanced decision-making strategies crisis emergency situations is substantiated. And thank you for your attention.
Okay. Okay. Colleagues, questions to Olha? So, Olha, what is the future work of your research?
Yes, good afternoon, dear colleagues, and thank you for the question. Our further and future work will consider the risk assessment and cognitive trust coefficient and coefficients of knowledge requirements developed for different complex systems and for different, let's say, if I may say that, hierarchical systems and investigating the operational management in emergency situation and developing all of those coefficients on our practical side. Yeah, thank you.
So that is the answer to limitations of your current approach, or its work in depth?
Yeah, it's a bit work in depth because nowadays we were using our results, testing of our results and testing our models using the received data from different types of students and from different courses. And we will proceed with the real data just to develop and to investigate our models and mathematical models among them deeper. Yeah.
Okay, thank you for your answers. Dear colleagues, some more questions? No? Okay, so let's move on. And who will be speaker? The report methods for detecting software implants in corporate networks. Who will be speaker?
Good afternoon, dear colleagues. I'm Kapustan Maria, and I will be speaker today. Please let me know if you see my presentation.
Yes, we do.
So our work is devoted to the methods of detecting software implants in corporate networks. And we have a team of 5 authors. It's Dmitro Denisuk, Thomas Sochor, Antonina Kashtalyan, and Oleg Savenko. Most are from our Khmelnytskyi National University, and Thomas is from Prigu University, Czech Republic. Do you see the second slide? Yes, yes. You do. Oh, okay, thank you.
Yes, we do.
With innovations in the technological sphere, the development of mechanisms that allow obtaining confidential information without the proper authorization of the owner is increasing, and one of such mechanisms is software implants. This type of software is very difficult to detect because it does not use specialized signatures or code obfuscation, making it difficult to detect. In our work, we propose a software implant detection system which is based on recurrent neural networks and a classifier. The classifier, we mean that's a mechanism that describes the operating behavior of the software and provides the recurrent neural network with the ability to learn. This mechanism helps to identify behavioral patterns characteristic of software implants and notify the user of the possible risk of data loss. Software implants differ from other types of malware in that they are more difficult to detect, especially because they differ slightly from standard program code. Additionally, parts of a software implant can be embedded in normal functions of a software product, making them invisible to normal monitoring and analysis. The importance of analyzing this feature is that implants mask their presence by embedding themselves in the normal circulation of program code. This ability reduces the possibility of detecting software implants, and also it requires the development of highly effective methods for detecting such malicious elements. So due to the unique nature of software implants, it's important that research focuses on their identification and the development of innovative analysis tools. One area of research is to develop a mechanism for detecting software implants in software products. The development of effective tools to detect these implants is defined as a step towards improving information security and addressing potential vulnerabilities to cyber attacks. Consideration of the mechanisms of implementation of software implants and their impact on the functioning of software products expands the understanding of challenges in the field of system protection and contributes to the development of strategies to counter these threats. Analyzing the characteristics of implants is important to identify their potential impact, which will provide more effective means of combining these new forms of attacks to the information system. Thus, the class of malware under consideration differs from the other classes in that it includes malware that does not reproduce or transfer on its own, but is embedded in useful software at the stage of developing it. Therefore, it is difficult to detect and requires the development of new and improvement of existing detection methods. There is a need to develop methodologies for detecting software implants based on mechanisms for analyzing the behavior of system components in order to detect software implants at the verification stage of a software product before its implementation in the IT infrastructure. We propose to use a mechanism for detecting software implants based on the analysis of the behavior of system resources relative to the expected behavior of the program, which is set through a classifier. Well, that's a nucleus of our work. The main characteristics of software implants that distinguish them from other classes of malware are following: no code obfuscation, lack of signatures, lack of direct comments in the source code on the software implant. The absence of direct connections with developers is an important feature of software implants. The ability to receive comments from external software resources, which is a key feature of software implants. It's ransomware, a program waiting for the team, and a program that provides remote access. Thus, the classification of software implants according to the certain features and criteria is the basis of the development of a new and improvement of the known methods of their detections. It means, seems I have already told that, sorry. So here on the first figure, there is an intelligent intrusion detection scheme based on anomalies. And also, I would like to mention the method for detecting software implants using a decoy system. The concept of it is presented here on the second figure, the concept of software implant detection system. And maybe more about our, well, the scheme for analyzing network requests, which are used. And to improve the efficiency of detecting software implants aimed at creating botnet networks, a multi-agent approach in computer system can be applied, and this approach can serve as an additional stage of system analysis. The multi-agent approach of detecting botnets in computer system is a methodology based on the concept of multi-agent systems to detect and counteract botnets. And maybe more in details about our experiment. We provided here is the algorithm for the system of detecting abnormal processes. This algorithm performs a number of key functions, and first it checks whether the process belongs to the list of configured processes, and next it checks the classification of the process and analyzes the resources it uses. A current neural network is used to assess possible threats. If the process is suspicious, the system tries to stop its operation, and if the suspicious process is repeated, the system generates information about its potential danger to the system. This approach is based on the use of scientific methods and takes into account aspects of process behavior analysis in order to effectively identify and eliminate possible threats. The algorithm for analyzing used resources and RAM content operates in accordance with the principles used in the algorithm for analyzing network requests. From analyzing the contents of RAM, the system compares the declared amount of allocated memory described in the classifier with the actual amount of memory allocated. As for the analysis of used resources, the system examines which files are used in the program and how they are used. For example, if it is found that the file that is not intended to read data in binary format at all, such as an image, is processed by as a binary file, this may indicate an attempt to manipulate the system through file input. Thus, the described method can be implemented, and the detection strategy set by the steps on this method is promising for further research. About our experiment, well, we involved software implants aimed at various tasks, such as collecting information and transferring it to the server. The implant waiting for the command is hidden in the image using steganography, and a program that provides access to the system console. Implants designed to create fake accounts. For the experiment, a recurrent neural network was used to classify software implants depending on their functionality. Its interaction with the network, operations with files, process management, and execute commands from the command line. The object for classification was a system specially designed for warehouse management. The classifier included characteristics related to the types of files that the software product processed, as well as a detailed description of the operations that could be performed on the files. The servers to which the program made requests and the console operations available to the software implant were also identified. Here are the results of experimental studies to perform the experiment an isolated system and a system that simulated other actions were used. In order to effectively train the recurrent neural network and correctly classify software implants, it was planned to spend 50 epochs training the model. The results of the experiment are presented on the next table, on the next slide, and it shows that data for every 10 epochs, and this allows us to obtain a detailed data on the detection and classification of software implants during the experiment. So here are the results, and as you see, we have obtained during the experiments, we found that the network was effectively trained for 50 epochs, and it was noted that the network demonstrated the highest efficiency when detecting software implants that initiate additional processes. The overall efficiency of detecting software implants that create additional processes was 98%, and the training schedule of the software implant detection system is shown here on the figure 5. Here are the conclusions for our work, and the further research work is aimed at creating automatic classification systems designed to automate the process of setting up a software implant detection system, and this will help reduce the time that is required to configure and put into operation a system designed to detect software implants in various types of software and information systems. Thank you for your attention. Please, if you have any questions.
Okay, Maria, thank you for your interesting report. Colleagues, any questions, please?
Which neural network are you using, LSTM or GRU?
I hope you hear me at the bad connection, but we are using a recurrent neural network.
LSTM or gated recurrent unit.
Recurrent unit.
Thank you.
You're welcome. Thank you for the question.
Okay, colleagues, any more questions? Okay, Maria, I have one more question. How will you reflect to the creation of new type of malware?
New malwares definitely will appear, and we will need to investigate it. It's a specific type of work. It works actually, and then maybe other neural networks can be used, or some other approaches taken to the classification, which we will use for its detection.
Okay, thank you.
Thank you.
No more questions. Okay, let's move on. So next speaker will be Artem Kachur. Are you here?
Hello. Yes, I'm here.
Okay, please.
1 second. Can you see my screen?
Yes, we can.
Okay. Hello, dear colleagues. Let us introduce our little research and methods of improving security and resilience of VR systems architecture. The agenda will be the following. So firstly, we'll do a small introduction with a general review, key aspects, motivation, and setting the goals of the research. And then we'll review the background with its aspects and methods and create an overview roadmap. Then we'll delve into problem analysis with its key problems and approaches to solve them, and make a conclusion, a comparative analysis of existing approaches. We'll define a need for a comprehensive solution and define the space for further research. So in general, VR systems have rapidly emerged as transformative technologies with applications spanning diverse domains, including but not limited to gaming, healthcare, education, and industry. This proliferation has engendered an imperative concern: the security and resilience of VR system architecture. Ensuring the integrity, confidentiality, and reliability of VR systems has become an exigent scientific challenge, given the potential consequences of system vulnerabilities, data breaches, and operational failures. So in response to these concerns, this work embarks on a systematic exploration of methodologies aimed at enhancing the security and resilience of VR system architecture. Through a scientific lens, we delve into an array of critical components and methodologies, encompassing hardware analysis, advanced data encryption techniques, firmwares, and operating system development, systematic stress testing and vulnerability assessments, hardware redundancy, and user privacy protection within VR and XR environments. The motivation behind this exploration lies in the critical need to address vulnerabilities and potential threats within VR environments. The integration of VR systems into various sectors underscores the importance of safeguarding these technologies against malicious activities that could compromise user safety, data integrity, and overall system functionality. So in the realm of VR and XR, virtual reality and extended reality, ensuring the resilience and security of hardware systems paramount as these technologies integrate deeper into daily life. This paper explores key aspects crucial for strengthening the hardware resilience and security of these systems, offering insights into enhancing the user experience securely. So here we can see our roadmap. An overview roadmap of some critical aspects of improvements of VR's environmental improvements. The first one is in-depth analysis of current hardware architecture. On the right side of the picture, we can see some methods which can help us do some job in this field, such as component analysis, benchmarking, and reverse engineering. The second thing is advanced encryption methods for data security. This can be achieved via algorithm evaluation, custom algorithm design, hybrid encryption models, and so on. The third thing is development of resilient firmware and operating systems for such environments, let's say. This involves modular design, intrusion detection systems, and fail-safes and redundancy techniques. Another important solution is stress testing and vulnerability assessment. It can be achieved via penetration testing, environmental stress testing, and automated vulnerability scanning. Hardware redundancy and fault tolerance is important. It can be achieved by dual system design, error detection and correction, and load balancing. They ensure system, let's say, continuity, and makes the system operational under failure conditions or extreme loads. And the last thing is user privacy protection, which is also important. And in order to achieve user privacy protection, we can use anonymization techniques, consent and transparency protocols, and data minimization strategies. Let's begin with in-depth analysis of current hardware architecture. So it's crucial for evaluating the current hardware architecture And this assessment includes addressing challenges like capturing all 5 human senses, optimizing variability and functionality, minimizing information mismatches, reducing wires, and addressing ethical concerns, all of which are vital for advancing immersive XR experiences. Approaches like virtual reality assembly assessment, VR2A, focus on the overall production engineer's assessment objective generating quantifiable metrics. The VR2A experiment design serves as an open standardized method for evaluating a VR system's geometric limitations in assembly assessment scenarios. By varying 2 parameters, clearance and assembly part sizes, within an abstract assembly task, the VR2A benchmark provides users with quantified insights into the smallest sizes and clearances for reliable assembly assessments. And on the right, we can see the overall VR2A score received by its creators in their experiment. Another approach is Maze Run VR. Actually, it includes a game developed using the Unreal Engine, which is quite popular, which features a procedurally generated maze that changes layout each session, preventing memorization of paths and ensuring a unique experience under 5 minutes to encourage repeated playthroughs. This design choice aims to explore user movement in all directions, evaluating their adaptability to dead ends and different locomotion methods: arm swing, walk in place, and trackpad movement. At the game's conclusion, players rate their locomotion preference on a 3-level Likert scale. This is how we can analyze the architecture and the usability of the system. Advanced encryption methods for data security. Security of such systems is of utmost importance. Custom algorithm design tailors encryption algorithms precisely for VR and XR systems, optimizing them to meet the highest throughput and real-time demands of these technologies. Hybrid encryption models amalgamate the merits of various encryption techniques, offering a well-rounded approach to security and performance. This balance is vital for maintaining seamless VR experiences without compromising data security. And one of the approaches is using visual cryptography. Methods which we have reviewed here is called T2VC, which means track-intolerant visual cryptography system. It's designed specifically for AR or VR head-mounted displays. And unlike traditional systems, T2VC splits confidential information into two shares displayed separately, allowing users to visually align and decrypt the message without relying on trusted computer bases or chain rests. Leveraging visual tracking modules, T2VC mitigates head jittering issues and enhances visibility through novel diffusion algorithm, making it practical and robust for real-time decryption. On the right side, we can see a comparison of T2VC compared with different parameters compared to classical visual cryptography. As you can see, it can be much more easily decrypted. Another approach is data hiding. Ensuring both high security and effectiveness is crucial in transmitting data, especially for satellite, remote sensing, and medical images. To address this, the completely separable, reversible data hiding and encrypted images, which SRDH stands for, algorithm is proposed. On the right side, we can see an overall review of this algorithm. The next step is development of resilient firmware and operating systems. Broadly defined as technology enabling visualization of complex data sets or interactive exploration of spatial environments, VR immerses users in computer-generated realities through sensory input and output device. So in terms of OS development, it's crucial to mention intrusion detection capabilities. VR networks confront significant security challenges, including vulnerabilities to malicious interference and exploitation by illegitimate users. Attackers employ various tactics, including eavesdropping and immersive attacks like human joystick attack, which manipulates users' VR experience to potentially dangerous ends. And on the right side, we can see a flow chart of a intrusion detection capable architecture. And since VR system can be tightly intertwined with IoT environments, an approach of IoT intrusion detection also can be used in development of such environments. And IDS, which stands for Network Intrusion Detection System, monitors internet traffic in IoT networks, serving as a frontline defense to identify and thwart intrusions and malicious attacks. Stress testing and vulnerability assessments are also crucial in ensuring robust environments for VR systems, and this process helps to safeguard sensitive data, prevent potential cyber attacks, and maintain a seamless and secure user experience in virtual environments. So to ensure successful implementation, it's crucial to assess whether VR simulations accurately replicate real-world tasks. Here we can see a method which provides a taxonomy of such behaviors and real-world tasks for further testing for vulnerabilities. Also, the public release of numerous regional and global digital elevation models provides a variety of options of studies to use in them for creating derived products for like orthorexification. However, comparing them is complex, and for accurate quantitative analysis, DEMS must lie in the same coordinate reference system. The paper, which we also analyzed, and the result you can see on the screen, introduces an enhanced disparity analysis methods, which achieves subpixel accuracy by interpolating linear regression coefficients within a specified exploration window, offering a refined approach to DEM comparison. Hardware redundancy. Hardware redundancy is actually a way of ensuring fault tolerance and resilience. By incorporating redundant hardware components and fault-tolerant mechanisms, our systems can mitigate the risk of system failures and maintain seamless operation, even if hardware completely malfunctions, or at least gets some errors. So in harsh environments like this, electronic circuits are prone to faults due to different reasons. In space, they are vulnerable to radiation. In more domestic solutions, they're actually more influenced by electromagnetic radiation. Let's say it's not of course the radiation itself. So redundancy is always used to mitigate such faults, and along with considerations for low power and small size, because we don't want the redundant hardware to consume more power than is expected, right? So we considered a study which evaluates TMR and VRPR performance for digital image processing, providing MATLAB-based and physical implementation results using a 28 nanometer CMOS technology. On the right of the page, we can see a flowchart of such system. And using FPGA-based hardware redundancy techniques can also significantly help in creating fault-tolerant digital filters for VR environment hardware. This increasing reliance on communications and signal processing in daily life drives the need for more reliable devices with minimal transient fault errors. On the right, we can see two flowcharts of such devices, which were developed by the authors of this method. To ensure user privacy and data protection, we should consider identifying users through tracking data and some other concerns about VR privacy. For instance, participants engage with a 360 degrees VR videos and complete questionnaires, and tracking data is processed using 3 machine learning algorithms. A limitation is if the collection of the participant data within short time frame without removing the headsets never exceeds 30 minutes. Consequently, some captured features may reflect session similarities rather than individual differences. And on the right, we can see some penetration test results for a system which implements this algorithm. And to conclude with, on those aspects which we have just reviewed, it's evident that each component, from in-depth analysis of current hardware architecture to user privacy protection, plays a crucial role in fortifying the overall system. However, the varied nature suggests that a one-size-fits-all solution is impractical. A comprehensive approach to enhancing VR hardware resilience and security should recognize the unique challenges posed by each aspect. For instance, in the in-depth analysis of hardware architecture requires a keen understanding of physical and logic and design vulnerabilities, while advanced encryption methods for data security demand robust algorithms and key management practices that are impervious to emerging threats. This means that ensuring the resilience and security of VR hardware requires a multifaceted approach. So in simpler words, we require a comprehensive system, a comprehensive environment which applies all the techniques and considers all the approaches and questions that we've recently discussed. And they should be worked on separately and thoroughly. Collaboration between hardware engineers, cybersecurity specialists, and privacy advocates is paramount in crafting sophisticated solutions that adapt to the evolving threat landscape. By embracing this holistic approach and adhering to international standards, VR systems can offer users a secure and reliable immersive experience. Thanks for your attention. Any questions?
Okay, thank you, Artem. Please, Vyacheslav.
Artem, thank you very much for your very interesting presentation. I have a few questions because your presentation is very close for our R&D activities as well. First one is which additional values you can get using attributes of resilience. I mean, you talk about VR systems, and you use attribute, you use conception of security and reliability and fault tolerance. Why you talk additionally about resilience? Which additional values are set we can get due to application of these resilience attributes? My first question.
Thanks for your question. Actually, resilience in the long run is a result of applying like an intertwined solution of all these aspects, right? It depends on what we determine by resilience. Usually, firstly, resilience is a very close thing to fault tolerance, right? And we
not completely. I think fault tolerance is the one issue. Resilience is other attributes.
Resilience is like more comprehensive. So I would say that fault tolerance is a part of resilience. To ensure fault tolerance, in this case, we consider hardware redundancy. But to ensure overall resilience, firstly, we need the system to be, let's say, strong enough to be able to fight with those issues that come in before we need the actual fault tolerance. And this is what we understand by resilience, if I understand your question correctly.
Yeah, I see, but when you said about fault tolerance, you demonstrate typical fault tolerance systems structure, and in this case we can use just reliability conception and fault tolerance, and when we talk about resilience, we need to talk about more dynamical situation, which connected with changing of requirements to system, changing of parameters of physical and information environment, specific faults and so on. In my opinion, I think in framework of your research, you can use reliability and security issues. It would be enough to demonstrate your results. It's a question of understanding of different concepts, conception. Hence, I think it can be a question for discussion. And my second question is, what about any metrics which can be used to assess improving of reliability, security, and maybe resilience in quantitative way?
Yeah, actually, there are some metrics on the method that we have researched on. Obviously, those metrics are different because because they all rely to different parts of systems. They can be accessed in the paper itself. Generally place a lot of metrics to the presentation. However, you can see it in the paper. For instance, for Maze Run VR, there is a plot of inertia and oculomotor locomotion methods comparison in SSQ score. Also about the redundancy, there was something metrical. I think there was a flip-flop metrics related to the 5MR configuration configured with the default algorithm and with the redundant algorithm and so on. Yeah, actually, most of these methods have some numerical metrics to be estimated.
Okay, thank you. And if it's possible, one short question additionally. Any example of specific vulnerabilities for VR AR software? You thought about vulnerability analysis of such components. Any example of specific vulnerabilities?
I don't think I can name a specific, a very specific vulnerability, like a specific, let's say, exploit. But in general, I would say that it's mostly related to intrusion detection because you see, VR environments can be used in very private situations like medicine, like healthcare, and intrusion actually breaks privacy a lot. So I think the intrusion detection is the most crucial thing in terms of vulnerabilities.
Okay, I see, but my question was about specific vulnerabilities for VR because it's very interesting topic, and I understand your answers general, but I think it can be very interesting topic for future research. Thank you very much.
Thanks.
Thank you to both of you. Okay, colleagues. Any questions? Okay, let's move on. The next presentation methods for assessing the risk of an emergency in the security system for the information complex of printed enterprises. Who will be speaker? Pablo, please.
Yep. Hey, colleagues, do you hear me and do you see my screen of presentation?
Yes, we do.
Great, thanks. So, yeah, everyone, welcome to the presentation. This research was conducted by a team from Ukrainian Academy of Printing and Lviv Polytechnic National University, including myself and colleagues listed here on the slide. Our presentation will cover several key areas, starting with the background of the issue, followed by the motivation for this study, state of the art, for the solutioning and risk assessment. And then we'll discuss the concepts of risks and safety, proposed methods for assessing risk, and conclude with experiment research findings within. The aim of our study is to examine risk and security within the control systems of printing enterprises, developing algorithms for risk assessment. The methodology researched here combines literature review with empirical analysis, leading to adaptable risk assessment methodologies and automated tools for hierarchical enterprises. For the background, in the rapidly evolving digital landscape, printing enterprises face unique challenges in protecting their information complexes from security breaches and external threats like war. The need for advanced risk assessment methods is evident given the sophisticated nature of threats and attacks targeting hierarchical automated control systems in the industry. The motivation behind the research was the vulnerability of these systems to cyber threats and limited focus on printing enterprises in existing literature and researches across the scientific space. The contribution includes some tailored algorithms for risk management in printing enterprises and filling in the gaps and offering a practical framework for risk evaluation for further research. First, about the analysis of risk and safety concepts. To understand what does it mean, risk involves forecasting future threats and assessing their potential impact. We define enterprise assets, threats, and vulnerabilities, emphasizing the difference between security levels, which measures current danger and risk, which forecasts future threats. On the right, you can see a risk matrix, which is relevant to the description of the issue, purpose of which is to facilitate the decision-making regarding where to focus risk mitigation efforts based on the combination of the likelihood of a threat or risk occurring and the impact it would have if it actually did occur. And the goal of the research is to provide algorithmic solution to calculate that and forecast that ahead of time. Two key concepts in their comparison is that the security level mentioned in the work is indicating our system's current security status and potential immediate losses. Think of it as now a snapshot of the system's health. And on the other hand, risk looks to the future while predicting possible threats and evaluating their potential impact using estimates like percentages or potential loss amounts, and acknowledging that there is always some level of uncertainty in such predictional situations. About the proposed method for risk assessment. The proposed method introduces a new approach to evaluate risk with printing enterprises information security systems. Key features here include custom risk management algorithms and automated real-time risk evaluation aimed at enhancing resilience against threats. With the purpose of introducing innovative approach here. We align on two key variables here, which is the security value, which could be considered as an input, and risk value as an output, which is basically a function over time. Main 6 conditions highlighted here are risk calculation basis, forecasting methods, risk relevance, direct association of the risk, current security level of the system and the enterprise in general, and security data, especially based on the historical evidence of the specific enterprise or the industry in general. For the calculated number of attacks, we have 2 formulas specified here. For the sake of argument, let's assume that the security level of the system is measured by the ratio of the number of successful attacks to the number of all attacks that were realized against. First, the number of successful attacks is determined based on the analysis and detection of anomalies resulting from such attacks on the audit of the system for which it is determined. Thus, the value of the number of successful attacks can be determined to that ratio. And second, we estimate the number of cancelled attacks and the number of such attacks, which are mostly recorded by the system even without applying such framework, is described by the ratio and the interval of terminal cycle of the attack and when countering threats. So basically over time. For example, in this case, B over V is determined by the failure of the hardware components. BU is safety due to control errors. BG variable is safety due to emergency shutdowns. And VI is safety due to emergency situations. In the first case, the attack is described by reliability parameters of hardware elements. And in the second case, by parameters that characterize the probability that a certain number of errors remain in the program after testing. An example of a model that describes the presence of errors remaining in the program system after testing is as the following ratio, where N is the total number of errors in the program, U is the sum of errors detected by tests, and the condition is the number of errors detected by iteration, and it's always less the general number of errors in the program, which some of them could not be detected yet. For determining the risk value, we assume that these 4 types of risks could be applied over time, but by the function mentioned in the previous slide. And we apply it. The result of it is the minimum sum value of the risks over time. To differentiate external factors, we divide them into 2 categories. One of the features of the risk assessment is the assessment of changes that may be reflected in the system in the event of activation of an event or by external factors. Since the system is affected by external factors that lead to the decrease in the level of security, in this case of using risk assessment, an event and an external factor may occur in different times. In order to distinguish these events from each other, we are introducing the following definitions: like regular negative factors and single negative factors. For RNFs, being the events known to the security systems, which the enterprise is mostly prepared for, and single negative factors are kind of like black swans or one-time events that can negatively impact a protected object and are not typically anticipated by the security systems and personnel. As a result, we've approached the multiplicative model here. This slide introduces it, which is used to calculate the overall risk for the active threats on the system components. Here, the alpha risk represents the risk factor, which is an average of the risks over time within the time frame T large and influenced by some delta. And the accompanying diagram on the right, figure 3, illustrates the timeline of an attack, its detection and implementation of countermeasures, emphasizing the dynamic nature of the risk over time. To apply it on a larger scale, there is a sequence of 5 stages of procedures that take place to calculate the risks over time. First is predicting potential threats to management and security systems, then analyzing action mechanism on the management system, synthesizing forecasts and loss estimations, examining the impact, and then systematically interpreting the risk value over time. For our experimental research and conclusions, we've reached out to system administrators of a number of Ukrainian printing enterprises in order to increase the reliability of the assessment of criticality, probability of implementations, and frequency of threats. Respondents were sent a diagram of dependencies between the assets of the automated printing production management system and a table with a list of assets and threats, the APMS, and were asked to assess the criticality, probability, and frequency of threats for each APMS asset, taking into account the dependencies between these assets as well as the vulnerability of these assets to critical threats. To assess the risk, we determined the damage caused to the organization if the attack was successful indeed. This took into account the fact that the risk cannot be completely eliminated and can only be managed to minimize losses from attacks and threats based on the assessment of the level of probability of negative impact for each impact factor. The solution was initially made in an Excel sheet, basically, and then transitioned into a web app written in JavaScript. For conclusions, we've analyzed the enterprise risks and security against threats, developed a modeling framework that could be researched further upon from that, established dynamic risk assessment conditions, differentiated anticipated and non-anticipated factors affecting security, proposed multiple security levels for operational stages, suggested automated risk and security assessment technologies, and researched applicability in security system design for complex structures. That's it for the talk. Thanks for your attention. Any questions?
Okay, Pavlo, thank you for your interesting presentation. Dear colleagues, any questions to Pavlo?
What method of attack detection do you use?
Sorry, could you repeat the question once again?
What method of attack detection do you use?
Here we've not worked initially on detecting, but rather analyzing the historical data of threats and attacks to the enterprise. Thus, we've reached out to system administrators. They've given the historical data and tried to apply that to a table and estimating basically the potential impact as listed on this slide. of different types of assets and how much risk appetite they include, meaning that, for example, the services, internal data, or the prestige organization presents much higher risk of failure and threats than archives and mobile PCs and networks. So basically, this data was driven by the survey that we've given to real people from different printing companies.
Thank you.
Okay, thank you, Pablo. Colleagues, any questions? Okay, Pablo, thank you for your report.
Thank you.
Let's move on. So the next speaker will be me. Okay. Let me share my screen. Okay. So, dear colleagues, let me introduce some results of our young team. Today we'll present a method for identify cyber attacks based on the use of social engineering of the phone. So, in our digital age, the prevalence of cyber attacks continue to escalate, posing the significant threats to individuals, business, and even nations. So, among these tactics employed by malicious actors, social engineers remained a pervasive and ambitious method for gaining unauthorized access to sensitive information. So, and we will talk about motivation, some background and main idea, and what some results we have obtained during the previous time. To start with, we have to understand what is social engineering attacks and what they are. Actually, it's kind of attack that can cause damage to organizations, societies, and the main potential consequences and damage from the social engineering, such as financial losses, data breaches, identity theft of the compromised system, maybe reputational damage, as well as the legal and regulatory consequences, psychological and emotional impact, spread of malware and ransomware, social impact, etc. To start with talking about this approach, a few words about background, because we started almost 13 years ago from different approaches employing multi-agent systems as well as network capabilities to some network malware detection, as well as some framework named Brother for cyber attack detections. And our new PhD students going to try find out and make some approaches for social engineering attacks detections. So actually, these kind of attacks are divided into technical and non-technical, where the technical attacks are phishing, baiting, tailgating, water hauling, spear phishing, spam email, as well as interesting software and pop-up windows. While non-technical social engineering attacks such as protection, face-to-face interaction, shoulder surfing, authoritative voice, technical expert, and such as support staff, reserve social engineering, and more. And in this case, the main idea was to investigate what is the problem while social engineers are applied over the phone, over some speeches. So the main idea was to make possibility to detect such kind of attacks based on the use of a unique linguistic word identifier. It's something like a signature method of detecting computer viruses. To do this, we have to obtain specified set of words that can characterized by a certain set of features and properties which, when placed in vector with their semantic proximity, are located next to each other. So in this case, it's possible to build a set of sentences or phrases which are usually implemented via attackers, and with the help of which we can possibly identify the attackers. So, few words about notion of unique linguistic wording identifier. So, this is a set of verbal utterances that perform speech statements that are directly related to the social engineer attacks of the phone. And just as this identifier for viruses, we can make clear define a class of social engineering attacks. Here you can see several examples of such linguistic worded identifiers, such as National Bank Security Service. We would like to inform you that your payment card will be blocked, or you have been created with non-refundable financial assistance from an international fund. Sometimes we can hear such calls from unknown numbers, and we can hear such speech. So, in order to find out to eliminate this problem, we are trying to make some approaches to find this fact. To do this, here are some message stages that include 3 steps: data representation, execution of the trading phase, and execution of the classification of obtained data. So the first stage includes a presentation of inclusion of feature instructions in order to construct the feature vector of such identifiers. In order to build the unique linguistic wording identifier, a set of relevant features are to be extracted. And the next step is to present them and as a multi-dimensional feature space. During the training stage, we have to include the obtaining data and build the labeled data set and feature scaling. After that, we have to prepare labeled data set where each unique linguistic word identifier is associated with a corresponding class, malicious or benign phone call. After that, we have to perform the feature scale procedure in order to normalize data, etc., as well as distance calculations, which is the most important part of this approach. So, execution of the classification stage in our case includes the distance calculations, the neighbor selections, and the majority voting procedure. During the classification phase, it's important to evaluate the distance, that is when we are classifying in U. Identify, we have to calculate the distance between the feature vector and the feature vector of the obtained data train set. To do this, we used Euclidean distance. And after the evaluation, the neighbor selection procedure is to be performed. And after that, we are to select the nearest neighbors based on the calculated distances. The last step is to apply the majority voting scheme to determine the class of the obtained data and find out whether the speech was malicious or benign. So here you can see the pseudocode of the key NN algorithm which was applied at the core of the classification. And let's go to the experiment results. So here you can see as the base of dataset, the main 2 databases were employed. First one, it's a go home at the part of TalkBank project. It's a specific collection of data which are related to the known telephone conversations, and some of them are benign, and some of them are malicious. And another part of dataset constructions involve information from the bank security service of the biggest bank of Ukraine. So we have, as a result, modified dataset that included 1,300 unique linguistic word identifiers, and using them, the system test included 30 conversations that were generated, included the properties of the cybertext based on the use of social engineer of the phone. In order to evaluate the efficiency, known metrics such as true positive rate, false positive rate, precision, recall of one score, and Matthews correlation coefficients were used. As a result, we obtained good results, and as efficiency, the result demonstrated high, up to 87%. And of course, the problem now is in the first, which is how can we obtain, because in this research we didn't include possibility to obtain conversation and to divide it into sentences and divide it into words, because it will be the next research direction of our research. But now it was just a prompt to build such sentences, to try classify them, build some data sets that will enable us to define which speech is malicious, which is not. And later, of course, we will try to include to our research maybe some NLP approaches in order to obtain information automatically from some speaker, and proceed further information to classify is it attackers or not. So thank you for attention. Do you have any questions? Colleagues? So if there are none, if everything is understandable, let's move on. And the next speaker maybe will be the team from Volodymyr Sabat, Bogdan Durniak, Miroslava Kulinich, Olena Havrilishin, or Pavlo Hibey, who will be speaker.
Yeah, it's myself again. Share the screen.
Okay, Pavlo, please.
Let me know if you see the presentation. This is green, just to check.
Yes.
Great, thanks.
Yes.
Okay,
please.
Welcome again. This time we'll speak about using semantic analysis of document text in building risk models in the threat systems. This research is a collaborative effort among multiple people from Ukrainian academic community, including Volodymyr, Bogdan, Miroslava, Olena, and myself. So here we'll cover the abstract background, motivation, state of the art, then jump into the section about the semantic analysis of risks and safety in the emergency events, discuss cause and effect relationships of design failures, system models of emergency situations, and slightly into experiment research and conclusions. The core objective of our study is to enhance risk management in hierarchical systems through complexity to semantic text analysis. By developing such semantic dictionaries and analyzing cause and effect relationships, we aim to improve early risk detection and enable preventative actions against emergencies. In today's dynamic risk landscape, traditional risk management methods fall short And in this research, we try to highlight the urgent need for innovative solutions like semantic analysis, which offers enhanced predictive capabilities and proactive strategies for technogenic system safety. Also, this research may set a foundation for how to approach the risk analysis through semantic analysis, and later apply it through machine learning and artificial intelligence. About the motivation, we observed the gap in existing risk management strategies, particularly a lack of dynamic adaptability and proactive measures, with the specific focus on Ukrainian language and Ukrainian library of works, also related to Cyrillic alphabet in general. This work introduces semantic text analysis to fill this gap, providing a more resilient system through early detection and proactive mitigation of risks. For the core concept, we've highlighted 5 of them: risk emergence, semantic parameters, impact on technical object, risks, safety analysis, and assessment process. Here we dive in the core concept of risk emergence, semantic parameters, and their impact on technical object. The assessment process we developed evaluates safety levels and permissible risks, crucial for managing hierarchical technogenic systems effectively. About the safety and risk diagram, this flowchart outlines the risk management process within a technogenic system, illustrating an interplay between automated systems, ACS and ADMS, the evaluation of dangers, attacks, and threats, and the strategic response mechanisms. It depicts the analysis and synthesis of risk factors, as we sum up here on the diagram, leading to strategies for addressing potential and realized risks, with a focus on maintaining strategic targets and security levels. The diagram also indicates the transformation of the system state post-attack, with components for situation analysis and strategy coordination, but does not explicitly label the elements in the after-attack state mentioned in the description, leading it to the situational awareness of the enterprise. For calculating the semantic significance, we see a critical formula in our risk management model. The function, second function J, transforms the current risk and the system component state into a set of acceptable conditions, mentioned as SC. When the safety measures of sigma over S exceeds our safety margin, it indicates a high-risk scenario. This leads us to a crucial decision point. If the risk and component state satisfy our safety criteria, then they're equivalent, triggering a predetermined response to mitigate the risk. This represents our system's capability to identify and respond to critical risks promptly. For cause and effect relationships of design failures, we dive into approach of hazard assessment, predicting maintenance malfunctions and detecting of design faults. This methodology is essential for preemptive management of maintenance hazards, aiming to prevent faults before they occur. Here we outline 2 approaches for hazard assessment. First, being analyzing past hazardous situations and assess losses, usually in value units. Mainly, this is relying on historical data. And second is model emergency situations to calculate potential financial losses as a measure of technical facility danger. This forms as a result of working through past hazardous situations. Here, we address how to predict and preempt maintenance malfunctions. Key points include understanding that malfunctions may be caused by factors both within and outside the system, often related to specific parameters. In the absence of detailed process information, we rely on prediction models for these parameters to anticipate malfunctions. Through analysis and predictive modeling, we aim to identify risks early, enhancing our facility security posture, and importantly, for those of-design faults within the systems which causes are not immediately known, we investigate a range of scenarios to manage potential hazards proactively. Formed model notation from the work describes the general two models, basically MN and MIN. The MN model is a function of parameters encapsulating how faults are mathematically described. It considers a set of parameters reflecting the different aspects that can lead to system faults, where we then extend this basic fault model to the MIN model, or MIN, which includes the initiation factors. This model is defined for all values where at least one of the following conditions is met. First is the probability of a fault exceeds a certain threshold, or second, the joint probability of a fault given another parameter z exceeds a different threshold. If any of these conditions are true, the fault initiation function is triggered, incorporating the relevant parameters specific to the specific scenario. Next, we simulate both external and internal parameters denoted here as for MI and MN for both models, and initiating them randomly based on known probability values at each step. And we check against certain fault conditions outlined in the previous relations. This process highlights our system's ability to adapt and respond to unforeseen failures, emphasizing the necessity of ongoing detailed analysis for robust fault management. Steps, the general stages that we have described to take for solving of design fault detection stages in such cases is first, we create models for emergency situations. Then we identify technical triggers, forecast external environment factors, develop countermeasures, and enhance the maintenance protection system, which could basically engage in a consistent loop to improve the system's protection performance. Factors and challenges that we've taken into account were environmental uncertainties or specific unforeseen changes or complex facilities or long operational periods, hazard assessment, design requirements, so from the get-going of the enterprise or the specific facility, and diagnostic tool challenges on a software or hardware involved in the production process. And to the experimental research and conclusions. So for experimental part of this research, we developed and rolled out an internally simulated environment of the intrusion prevention system, which was based on the analysis of structure of the production infrastructure, the strategy of attacks on the infrastructure, and countering attacks. As a result, a model of the information and the system game of the attacking structure aimed at destroying the infrastructure of this hierarchical automated control system. We're still in progress of providing more specific results, and our group of researchers targets production-ready testing of document management system in the near future, with plans to engage with the machine learning algorithms. The specific complexity here is the real-time approach, since gathering enough historical data to improve the system without giving false positive results is complicated. And since targeting and at Cyrillic alphabet in Ukrainian language, this increases complexity slightly at the moment. So for conclusion, semantic analysis effectively predicts in our internally simulated environment and manages risks in technical systems. We've achieved early identification of non-design faults to diagnostic metrics, and we've transitioned from reactive to preventive security strategies, which may enhance the system's reliability by focusing on preventing malfunctions before they occur. That's it for the presentation. Thank you. And do you have any questions?
Okay, thank you, Pablo. Please.
Are you using an expert system?
Yeah, this was one of the considerations. This specific approach lacks expert system right now. We are considering this in next iterations because this approach was strictly algorithmical, and without having a substantial amount of data, we were not able yet to distinguish a specific set of experts that could differentiate, for example, targeting different types of threats or semantical features of the text that was given in the data set.
Thank you.
Okay, Vyacheslav, please.
Thank you for your presentation. I have two questions. First one, please come back to slide with model of faults. This one. Could you very shortly comment concerning what kind of faults you analyze? I mean, usually if you talk about critical infrastructure or safety, we need to analyze critical faults. How you classify faults in this point of view? It's my first question.
Yeah, so here, first, if we look and the first condition for default model that is described as a function of parameters, we were trying to enter a set of texts which could potentially have some harmful parameters. Thus, they were not described specifically as something that could halt production, but rather contain some negative sentiment. And as a result, we could highlight that to the enterprise and simulate that in our environment. So right now, at this specific moment in the research, there is no like completely fault-tolerant approach, rather a framework that we could set the ground of foundation for the specific research in the next stage.
I see. And do you use any risk-oriented assessment as usually applied for criticality assessment?
Yeah, we are planning to engage with the previous work we've just discussed like 15 or 20 minutes ago with the risk framework, the threat detection and risk detection framework that we discussed previously.
Mm-hmm. Okay, thank you. And second question, please, your case studies slide. Could you say something about this system, because it is a very general structure, if it's possible? What is a system?
Yeah, this was a try-on simulation on a very basic system of setup with multiple servers and a simulation of an enterprise with client-server infrastructure, where the inputs were the texts coming in from the client, and the server could make a decision-making based on the inputs coming from client. Thus, in the server, there were a set of toggles, switches on and off, basically simple simulation, and based on the risk evaluation approach that we have here on the semantic analysis, we could decide and make a simulation going, for example, from 0 to 1 on a scale from 0 to 1, with a set of analysis values that could provide us with information on whether the information coming from the input was harmful or not. The diagram here is pretty generic, but it just includes the main moving parts in some slightly over-detailed manner.
Okay, and very shortly, what about choice of countermeasures against attacks? You have one module strategy for countering attacks. Which kind of criteria you use to select countermeasures?
Yeah, first, given the historical data that was analyzed and giving us an input manually, and then based on the historical trend coming in from the new inputs, we could evaluate whether the new input matches previous results from the data set, and thus we could evaluate whether the new input is actually harmful, and thus the countermeasure will trigger, which is in simulated case was basically to proceed or not proceed with the operation.
Thank you.
Thank you for questions and answers. Any more questions, colleagues? Okay, thank you, Pavlo. Let's move on, and the next presenter, I suppose, will be Evgeny Sergeyev. Are you ready?
Yes.
Please share your screen.
Thanks. Okay, do you have my picture?
Yes, everything is good, please.
Okay, excellent. Hello, I'd like to welcome everyone. I am Evgeny Sergeyev, a postgraduate student in the Computer Engineering and Information System Department. And I will be presenting a report, graph-based vulnerability detection method. Introduction. The field of software security is rapidly changing due to advanced technologies such as cloud computing, widespread adoption of Internet Protocol version 6, and significant advancement in machine learning. This innovation have enabled the development of complex software systems and new methods of data management and access. However, the complexity and interconnected nature of modern software systems have increased the risk of cyber attacks. Vulnerabilities then can be exploited through sophisticated techniques, including SQL injection, cross-site scripting, and buffer overflow, are among the most critical threats to these systems. Software vulnerabilities can provide attackers with opportunities to compromise system integrity and confidentiality. Traditional methods of detecting vulnerabilities, which rely heavily on static and dynamic analysis, are no longer sufficient in identifying and mitigating these emerging threats. As a result, it's critical to develop innovative approaches that can better detect and prevent software vulnerabilities. It's essential to create new, more effective methods to secure software system against these advanced threats to ensure the security and reliability of the digital infrastructures that underpins of modern world. Classification of vulnerabilities in software. Software and digital services are vulnerable to various threats such as design error, software flaws, and security breaches. It's essential to identify these vulnerabilities to ensure the security of information systems. Our graph-based vulnerability detection methods, or simply GBVDM, target specific vulnerabilities, including SQL injection, cross-site scripting, and buffer overflow. Our innovation approach uses dynamic analysis to improve detection rates and reduce false positives. It aims to enhance traditional detection methods by providing a comprehensive solution that not only identifies existing vulnerabilities, but also predicts future threats. This approach ensures the security of software system by identifying and addressing vulnerabilities effectively. Relative works. Cybersecurity research is of utmost importance for the development of advanced vulnerability detection techniques. The goal is to identify and neutralize potential threats. Innovations such as machine learning and deep code analysis can enhance detection efficiency and accuracy. Machine learning has opened new horizons in cybersecurity. It offers more automated and adaptive systems for vulnerable detection. This is crucial for continuous adaptation to new threats and reducing the occurrence of false positives. Key methods include support and service scanning, software vulnerability analysis, penetration testing, and monitoring event logs. These techniques used individually or in combination provide a comparative approach to ensure software security. Despite significant advances, challenges like adapting to new threats and managing false positives persist. Continuous research and innovation are essential for developing more effective cybersecurity strategies. And more about our methods. In our quest for advanced cybersecurity solution, we developed the graph-based vulnerability detection methods, a novel approach that integrates with current technologies for deep analysis of software dependencies. By mapping out software components and their interaction in a dynamic dependency graph, GBVDM pinpoints potential vulnerabilities with higher precision, including SQL injection, cross-site scripting, and buffer overflow. This method excels in analyzing large complex software system by employing static analysis tools to identify all program elements and their dependencies. Utilizing machine learning, GBVDM not only detects existing vulnerabilities, but also anticipates future threats, significantly enhance software security from the early development stages. The dependency graph, represented as directed graph G, represent a graph composed of vertices C and edges E, facilitates operations such as degrees of dependency calculation and path analysis, enabling an comprehensive risk assessment of components based on their dependencies and importance. This innovation approach promises a more effective defense against evolving cyber threats, underscoring the needs of continuous research and adoption of cutting-edge technology in cybersecurity. We made some experiment studies. So our comparative analysis between the static application security testing, SAST, and our graph-based vulnerability detection methods, GBVDM, on software designed for Windows 10, featuring about 1,000 components, revealed GBVDMs super efficiently. Notably, our methods detects 141 vulnerabilities compared to SAST 112, with fewer false positives. Also, our methods required additional analysis time. It's it's a bad point, but we think it's a good price for more effective analysis as a result. If effectively uncovered 250 complex dependencies not identified by SAST, enhancing our understanding of application architecture and potential security risk. In conclusion, the battle against cyber threats is ongoing and critically important, underscoring the needs for continuous development of advanced cybersecurity methods like our GBVDM. This approach has proven to be more effective than traditional methods, such as SAST, in detecting vulnerabilities with greater accuracy and fewer false positives. The interdisciplinary nature of cybersecurity demands collaboration across government, private sector, and academia to foster innovation solutions and establish robust standards. Our research into GBVDM highlights the potential of integrating cutting-edge technologies, for example, like artificial intelligence and machine learning, to strengthen our defense against cyber threats, paving the way for a safer cyberspace. Thank you for your attention.
Thank you, Evgeny. Colleagues, any questions?
Are you planning to use a Bayesian network?
Sorry, I have a lack.
Bayesian network. Are you planning to use a Bayesian network?
No. For now, we are looking on machine learning directly is learning with reinforcement, because we cannot have a full result, for example, for simple neural network, but we can create a bonus table for good points and bad points and learn our future machine with this bonus table. I hope I answered your question.
Thank you.
Okay, Evgeny, I have one question. I saw that you have high false positive rate. What is the main idea maybe for future work, how to decrease the value of false positives?
As I mentioned before, I think it can be solved by machine learning. It can test or analysis and give us verdict about its false positive or true positives. Because directly from analysis, it was too hard to determine which is positive. If we are looking for a huge program with a lot of components and dependencies between them.
Okay, thank you. Vyacheslav, please.
Thank you for your presentation. My question is, please clarify one more concerning graph which you use to detect vulnerabilities. I mean, what is in this case nodes and links between nodes, and how this model can be applied for detection.
Okay, yes, thanks. Our dependencies, it's simple, include our project files or call function from another classes or files. It's what we mean by dependencies between components.
Hence, the main idea is analysis of dependencies of between components to detect vulnerability.
Yes, because for now the most popular methods it's open, so a lot of program use this approach, and our methods it's good for this cases.
Okay, maybe would be right to compare result of your methods with result of search vulnerabilities in open database, similar NVD and other ones. Did you compare your result with such open databases to verify your result?
Yes, we found results for our table in open resources for competitive methods, and in the future we plan to compare our methods with others, also from open database.
Okay, thank you.
Okay, thank you. So the next presenter, who will be speaker, Olena or Vyacheslav?
Olena.
Please.
Hello. Can you see my screen?
Yes, we can.
Okay, I'm Alena, and let me present a topic of my research. It's analysis of AI-powered attacks and protection for UAV assets, quality model-based assessing cybersecurity of mobile system for demining. I'd like to start with motivation and state of the art. Next will be defined the object of the research and the goals. After I will be short overview of current cyber attacks on UAV systems. Next will be identified some main barriers for integration AI into UAV systems, and then will be proposed countermeasurements classifications for all threats and attacks. And finally, I'll show a case study for requirement standardization for AI components depending on specific tasks, and ends up with conclusions and future research. In general, mobile system can be divided into three groups. It's unnamed ground vehicle, unmanned autonomous or aerial vehicles, and underwater vehicles. This research mainly focused on UAV systems. Modern UAV systems are wide-ranging in a lot of sectors, civil, military, and commercial. And nowadays, the most significant usage is observed in Russian-Ukrainian war. Also, alongside with legal usage, there are concerns regarding potential criminal and terrorist usage. Also, with the integration of AI into UAV attack surface keep increasing. In our according to the Web of Science metrics, a lot of research dedicated to security of artificial intelligence, as well as UAV security, but much less focused on AI security in the UAV systems. In our previous work, we proposed simple chain where AI can be considered as protected asset, as countermeasurements, and as AI as tool for attack enhancement. It allows categorize of scenarios in the intersection of AI and cybersecurity, which require detailing for UAV systems. Our main goals was to analyze possible threats and attacks in context of UAV and AI, to justify the selection of countermeasurements to enhance the cybersecurity of UAV system, considering their vulnerabilities and use of AI. Objectives are following. It's to identify the main barriers to implementation of AI in UAV systems, propose and classify countermeasurement considering the aspect of AI, and describe case study of building quality model to assess AI-based onboard system and protection means for UAV applied for demining. I want to start from a short overview of existing attack on UAV system. It could be split into 7 parts. First, it's attack on drone operator, for example, unauthorized access, social engineering, insider threats, and so on. Malware infection take place in the ground control system. Next, we have set of attacks to the communication channel between drone to ground station, drone to drone, and drone to cloud. For example, eavesdropping, jamming, man-in-the-middle attacks, and so on. Separately, we can have some attacks on cloud services and for drone components such as GPS or telemetry spoofing. It attacks still exist, and for some of them, still a lot of UAV remains vulnerable. Considering the rapid development and popularity of AI, it's logically that AI used for UAV automation. However, it's problematically to achieve the full automation out of the nature of AI technology, because by default, AI it's not robust. It's vulnerable for some specific type of attack that cannot be easily fixed. According to the Blackley Declaration, the main identified issue using AI is transparency and the explainability of AI tools, because most of AI tools are not explainable by default. Next one, it's a personal data collection by AI system and uncontrolled or malicious use of AI. Also need to remember when we try to integrate AI into UAV system, restrictions and some limitation of onboard UAV system. There could be or computational power or memory that in a lot of cases decrease some functionalities and effectiveness of AI models. Let's dive deeper into this topic and see the most common AI attacks. First, it's adversarial attacks. In general, attacker in adversarial attacks manipulates input data, adding some adversarial perturbation. And it leads to incorrect model behavior. It could be digital or physical. Next set of attacks, it's a poisoning attacks. In this case, attacker manipulates training data. And in case of indiscriminate attacks, the main goal of the attacker is to just decrease overall performance of the classifier, for example. or in case of targeted off-backdoor attack, it just purpose to have another behavior in specific cases. Also, we have some types of attack for model or data extraction. It includes architecture parameter stealing from the model, behavior stealing and constructing a surrogate model, or it could be training data reconstruction. Moving forward, let's focus on attack in AI models in UAV systems. Was found several attacks for this, and one of them is add-to attack. This method proposed a new approach where adversarial examples were generated during regeneration process of visual data in object search process. Due to vulnerability neural networks to adversarial attacks, CM's trackers that used can be easily hacked by minor changes in the input image and resulting to incorrect position determination. That poses a huge threat to UAV tracking tasks. Nevertheless, despite of AI problems with security, AI remains one of the most promising and best solutions for many tasks. For example, solving some computer vision problems such as real-time detection, object detection, tracking, collision avoidance. Also, it could be used for monitoring and detection anomalies by analyzing data from external and internal sensors, optimal deployment, etc. Based on analyzed information, we're proposing following threats and countermeasurements classification. In general, threats could be classified into AI-powered and traditional, and countermeasurement could be applied into two levels. It's regulatory and technical. To the AI-powered threats, we can see it's AI or AI-generated telemetry or GPS spoofing, all adversarial attacks, and fully automated UAVs. All remained threats can be considered as traditional. At the regulatory level, AI regulation and standardization involves controlling AI usage and with implementing some technical standards that allow to avoid these falsification attacks. Also should be a regulation and standardization of UAV systems. For example, restricting usage UAV near some critical structures, critical objects, and usage of forensic techniques to incident investigation and incident response strategies development. Moving to the case study. Here, one of the approach to standardization of AI models, it's to choosing key characteristics for each model. That depends on specific tasks. In this case, we have two tasks. For AI model, first, it's a general AI model for demeaning tasks, and AI model as protection mean. In this case, AI quality model, it's a hierarchical structure that have all characteristics of AI. And in this case, we can define which characteristic will be important in our cases. So, for example, in case when AI used as protection mean? We can disregard, for example, ethic, lawfulness, and safety because it will not lead to any critical consequences. Second, methodology that we propose for enhancement the cybersecurity of UAV system is using risks assessment, meta-analysis that based on chains, threat, vulnerability, attacks, effects, and assessment of criticality. And in this case, this allows to evaluate the contour measurements and evaluate the risk. In general, we have contour measurements, and we need to define what contour measurements can decrease the parameter of risk or probability of attacks or severity of consequences. And by comparing these contour measurements, the best option could be chosen. Finally, the main contribution of this study is a classification on threats and countermeasurements. Proposed systematization consists of regulatory methods aimed primarily at legalizing use, standardization, and quality control of UAVs and AI. And the future research can be devoted to developing methods for assessing countermeasurements and analyzing attacks on UAV equipped with AI systems, and study of combined attacks, development of attack graphs, as well as investigating the impact of parallel and sequential attacks. That's all. Thank you for attention.
Thank you, Elena. Dear colleagues, questions?
What methods have you choose?
Methods of what?
You proposed a lot of methods you choose from this set methods.
For enhancement cybersecurity of UAV, we proposed only two. It's usage of quality models and risk assessment.
Thank you.
Okay, colleagues, more questions? Okay, and what will be the next approach? What is your next direction of your research?
The next direction we are proposing using this meta-analysis, and it will be actually used with examples like in this one, but for full full risk matrix for each attacks. It would be extended variant.
It's a huge work, actually. Okay.
Yeah.
So good luck in this direction. Thank you for your presentation. Okay. So the next, who will be presenter? Sergey Danchuk. Are you here?
Hello. Are you hearing me?
Yes, we hear. Okay, start, please.
Hello, dear presents. I'm going to present you the report on the topic method of detection cyber attack of communication channels based on spectral clustering and machine learning method. This report is presented by Sergey Danchuk, a student of Khmelnytsky National University. Introduction and motivation. In today's digital world, where communication networks are an essential component of virtually all aspects of life and activities, The importance of detection cyber attack of communication channels becomes critical. The increasing reliance of technology and the widespread use of the internet lead to an increase in digital information in defense, but also to rise to the number of threats and attacks aimed to disperse the intelligence confidently and reliably to choose a channel. Cyber attack on communication channels can lead to serious consequences, includes loss of confidential information, privacy breaches, finance losses, and even threats of national security. Attackers using various methods and technologies attempt to exploit vulnerability in a communication infrastructure to gain unauthorized access to system and data. The use clustering methods and random forest is a relevant strategy to detect cyber attack on communication channels as the allow adapting of complex conditions in cyberspace and ensure the effectiveness the detecting the response. Detecting method of cyber attacks on communication channels based on a combination of spectral clustering and random forest. The proposed method for detection cyber attack on communication channels in TCP/IP networks based on spectral clustering and machine learning methods includes the following steps: collect and normalize data, application of spectral clustering, obtaining clusters, machine learning classification training, and machine learning classification testing. The method of detection cyber attack of communication channels involves analyzing the communication channels, specifically TCP/IP connections. Clustering method is utilized for analysis. For detection DDoS attack using spectral clustering, it is crucial to have diverse network traffic data, which is used to construct a matrix suitable for the processing using clustering algorithms. The following features were used to create the simulation matrix and number of requests to the server with a creating time frame, a total data volume transmission by all network packages, the number of unqueued IP address instructing with the server, and the server spends processing requests, the number of fields connection identification attachments. We use NSCL KDD dataset and use it in practices. Intelligent data collection can also be applied. Since some data is discrete, min-max normalization is applied. The model of spectral cluster algorithm with is a clustering algorithm based on the spectral analysis, which directly used stable spectra compared to traditional clustering algorithms. Spectral clustering can be better partitioned to the data samples into cluster with height similarity regulates of a simple space. The working principle of a spectral clustering algorithm is follows. Firstly, the data of a simple set transformed into similar matrix, which reflect to similar between simple data. Next, the equivalence and equivalence of a matrix of computed. Finally, the future vector is selected, which we can effectively cluster for data. For the comparison, we use three classificators. Random forest is based on the fundamental concept of ensemble learning of a training series of decisions tree and refine them according of the characters of each tree. During the train of a random forest attribute are random selected and enhance and relative independence over formed discussed trees, leading of improved performance in the traditional discussed trees when the number to nodes equals n, the choose the best attribute is a base on all n attributes of the nodes. In the random forest, each discussed tree node is based on k randomly choose attributes, where k is a crucial parameter of a degree of randomness. Additionally, the value of k can be 1 or 0 corresponding the randomly selecting an attribute or using a method of selecting via standard discussed tree. One moment. The naive bytes is a set of learning algorithms based on the application of bytes, whereas a naive assumption of conditional independence between each pair of future given the class variable. Classification can be extremely fast commander or more complex methods. Separating the distribution of conditional futures and class means that each distributional can be independent estimations and various distribution. This in a turn helps to lower problems for the course dimensionally. We use this classificator to determine where data in the cluster of anomaly. And JSON algorithm is the classificator algorithm that construct discussed tree based on information theory is an extension of a previous ID3 algorithm by Ross Quinlan, also known as JSON in where J stands of Java. And training experiments and evaluation. This experiment use an LCD KKD dataset is until serving as an effective benchmark of instruction detection method if the subtract number of records of both training testing set. We used conducted experiments of a full dataset without need to randomly select a small sample. In the experiments of type attacks, we are consist three DDoS attacks, brute force attacks, and authentication slowing attacks. Those attacks triggered of high number of requests to the server with a certain period of time, loading the server overload and describe availability. Brute force attacks increase the number of field connection over the authentication attachments, and attackers try to actually large number of combination gain access to the system. Slower attack during the attack to average time the server spends process request increased as attacks keeps connection open, delaying the termination and overloading server resource. Training was conducted based on the cross-validation principle, where each experiment until is a subset of data not used in previous experiment. This model is used to test to training model where over dataset become available. Training of the model is done on the training set, and the model is tested on different subtests in the set. And a result of experiment, the performance of spectral clustering method with random forest algorithm is compared with spectral clustering method using JSON and then 48 and native bytes algorithm. As shown in the table, the spectral clustering algorithm based of random forms proves to be more effective compared to J48 and naive bytes. Experimental results indicate the semi-supervised learning model proposed in the article. Achieve a high accuracy, has a low false positive rate, and demonstrate good efficiency. This method is better situated for detection channel attacks compared to the detection model. According to the experimental results, propose methods slow high effectiveness in detecting new types of network traffic data attacks and maintains relative low false positive rate is outperformance J48 and naive in all speech such of sensitive specialty and accuracy. And it's all. Thank you for attention. Question.
Okay, thank you for your presentation, colleagues. Any questions?
Why did you use spectral clustering?
Because with machine learning, we can separate information and use classificator for find anomaly in this cluster and security with more effectively find cyber attacks on the channel.
Thank you.
Okay. Sylvia, I also have a question. Actually, as far as I understand, you have combined two known methods into one to obtain good results. Is it true?
Yes, I combine two methods. It's clustering and machine learning because it's more faster and we don't need to we check with to random forest is more have more performance and we don't need to check all information because we have a cluster and we have a classificator. He learn in test the data and he check fast if cyber attack of channel on the channel.
Okay, I see. So the question is that you said that it is faster. In what situation it is faster? At the stage of training or evaluation of testing? When it's faster, when you are training the system or model, or when you are testing the model?
When I testing the model. After the training, we can more faster because classificator know what we need and more faster to find special attribute on attack.
And the last question, have you assessed or evaluated the complexity of your new method? Maybe it's faster, but it needs more resources to process the data.
Yes, it's more faster and it's need more resources, but it's need to more resources for learning. But after we don't need more resources, we have a system, and maybe we need later. But now it works and more faster than standard methods.
Okay, thank you, Sergey. Thank you for your presentation. Any more questions, colleagues? No? So, thank you. And the last but not the least presentation, maybe it will be Pablo.
Yes. Hello, everyone.
Okay, please share your screen.
Maybe I should share only.
You have shared not presentation mode.
Is it looks better?
The same. Okay.
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 Okay. Hello, all the participants of the conference. Today, I will introduce the article with the topic, a trust model that ensures the correctness of computing in grid computing system. In the model world, distributed systems occupy a significant position in information technologies and being applied to solve a scientific task and handle various services. And IT scientists provide several approaches and methods for organizing and operating such systems. And the organization of distributed system depends entirely on the task set before the system and the nodes that it employs. Grid computing systems are characterized by their ability to work with different heterogeneous nodes, and each node has its own level of autonomy and allowing it to participate when it needed for node actually. And also we can define that nodes does not belong to the system if in comparing to the traditional computing systems. And these systems involve collaboration among a huge number of nodes, making the use of intermediate servers to keep the entire system operational in a primary organizing approach. On the one hand, the system operates solely with the elements that do not belong to it, presenting challenges such as security, synchronization, and load balancing concerns. On the other hand, this type of system can achieve significant computational power. And one of the best examples of utilizing such architecture for distributing computing tasks is volunteer computing, which combines computing resources from individuals who wish to contribute to important tasks on a voluntary basis. Therefore, all the nodes have the following features that should be taken into account. So from the point of view of the central unit, all nodes have unique set of software and hardware. System cannot trust any work that being performed on node, and nodes may stop participating in any moment of the time. And we have to ensure that the computed was made correctly, and we define the concept of trust model. And trust model are widely used in various areas, and they have one key task is performing the correct identification of the node. The primary concepts of such model are based on approach such as reputation, voting, blockchain, game theory, behavior, and machine learning. The proposed trust model will utilize the reputation, behavior analysis, and machine learning approaches. To ensure the correctness of the computing process, it is proposed to assign roles to each node to node within each subsystem. And we defined four major roles. It is trusted node, common node, new node, and untrusted node. These roles will be determined based on the current rating of each node
and its behavior, which may change over time. And each node also entails different tasks that can be performed by the node at any given time. After the system in the task distribution model allocates tasks among connecting nodes and awaits the results of their computation, the trust model will aggregate all obtained results and compare them with the results obtained by trusted nodes. If these results are equal, the computation will be deemed as successful. Afterwards, the formula used to adjust the rating for each node, which determines its current trust rating and demonstrates this below. According to this formula, the value may change as the nodes perform their task. Let's talk about conflicts that may be caused by the voting system. And conflicts may arise when computing results return to the system the trust model. And each sub-system has at least 3 trusted nodes that check the computing results for other nodes. If all the nodes return different results, conflict occurs. To address this issue, behavior analysis is proposed. For this modified trusted model, it is proposed to collect information that will be used to characterize each of them. And the collected data may be divided into 2 major categories. It's identificational data and computational data. All this information is combined into a single record that represents each node's participation in the time. So when each computing node performs some task, it returns the result of it, and software that drives this information to the server will also send this combined information. Obtained data was used to train model to perform the binary classification that will be used for prediction in any of node was compromised. And when conflict appears, the subsystem may use the activity records of any node to check if any of node was compromised. And shown graphs shows the training speed of model and prediction accuracy, both based on the number of epochs. And let's finish with the conclusion and future resources. So the maximum accuracy of prediction was achieved with the larger number of epochs to train the model. To achieve the higher prediction rate, the model requires more time to train, but the accuracy improves slowly compared to the training time. It is necessary to find the optimal number of epochs to prevent the model from becoming overfitted. And it also necessary to create a single model for all computing nodes in the system to research if this will help to achieve the higher rate of prediction. In this case, the collected information that was demonstrated on the previous slide should be reconsidered, because on the current project version of the project, we create a model for each node that participate in the system. Thanks you for your attention. I will happy to hear your questions.
Okay, Pablo, thank you for your presentation. Dear colleagues, any questions? Okay, I'd like also to give a question concerning the complexity of your approach. Have you evaluated it?
Well, it is your question should be considered from different viewpoints. Well, in this experiment that was performed, the complexity was not high because the number of records was not high, and in this case, the training of the model that should find the faulted node was very fast. And in this case, it causes two major things. The first one is accuracy was not high enough as we expected, because we need to achieve at least 90, maybe 95%. And complexity will grow when we will combine all the records to train a single model. Thank you.
Thank you. Some more questions, please. No? Okay, below, thank you.
Thank you.
Dear colleagues, my pleasure to inform you that our section is being ended. So thank you for your very interesting presentations as well as interesting questions. I suppose we will see you next year. Thank you. Bye-bye.
Thank you.
Dear participants, now we have a coffee break, and we invite all to awards and close ceremony, which will take place today from 5:30 p.m. 4:30 p.m. after 20 minutes. Okay? We are waiting you.
Thank you.